Yeah. Good evening, everyone. Sushani here. Let's start off. Sure. Everyone, others scams on. Where are the rest? So we have done with capacitors last time. We'll be starting off with a new chapter, current electricity. Quite an important chapter. There's a decent weightage. Reason being, one, the chapter is little big, right? And the second thing, in JE, right? Normally there's a topic called experimental physics. So we have around 10% weightage for experiments in physics. So in experiments, you have potentiometer, ammeter, voltmeter, meter bridge. So all these things will come under current electricity also. This will also come under the category of instruments. So that way, this thing literally comes in two different chapters, even though the concepts are same. So that way, it is quite important. So let's start it off. So we have done a lot of circuits, but here we will do a little different ones also, which we couldn't do in capacitors. But other than that, all the techniques we used is same. But circuits is only a part of it, like, 15-20% of the chapter. Remaining, there are multiple things. So let's start off. We'll start off with the definition of current. So current is simply rate of flow of charge. Viksha, your cam is off. This is been a month. You need to really do something about your cam. Next class onwards, I won't allow you. So rate of flow of charge. The direction is pretty simple. It is a rate of flow of charge. So the direction is given by direction of current is the direction of the current is in the motion of positive charge. Direction of motion of positive charge. So the guy whoever defined this thing, right? They defined in terms of positive charge ka flow. Example, if you say sodium ions and they're traveling this way, you can say current is flowing this way. The symbol for current is I. Suppose if you have electrons and the electrons are moving this way, electrons are negative charge. So this thing, the current will go in the opposite direction. Clear? So the flow of the direction of the positive charge is taken as the current ka direction. So if the negative charge is flowing, then opposite to the negative charge is taken as the current. So the problem here is what? In reality, the current flows because of electron ka flow. And sadly, we define the electron as a negative charge. You get the point? So actually, we should have defined electron as a positive charge and proton as a negative charge. Convention would have been easy, but for some reason, it is already defined. So we can't do anything about it. Now, changing all the books and reprinting them again will cost a lot. Clear? Now, so going for the definition of this, I is equal to dq by dt. So we can write q, which is charge flow, is integral I dt. So if someone asks you to find the average current is change in charge by change in time. So if you plot an I versus t graph, This is the positive area. This is the negative area. So the area under IT graph gives you charge flow. So this is your charge flow, which is nothing but area under current n versus time graph. If they give you current versus time graph and they ask you charge flow, you have to find the area under the graph. If you're taking Q versus time, then the slope in QT graph gives you current. Check. So dq by dt is current and integral I dt is the area under the graph. That's the charge flow. So
Sir,
technically speaking, this is the main thing.
Sir, when we do summation, we take off that areas with sign.
What? Positive, negative likha tha na? Area above the time axis is positive, below the time axis is negative. Have a look at this. So if you see current ka definition is pretty simple. I is dq by dt. Clear? All clear with the definition. Reina? Clear? Abhiksha? Got this? Hasni? Risha? Can I go ahead? Nishita? Clear, na? Great. So, current is not a vector quantity. Even though current has both magnitude and direction. If you see current has a magnitude 5 ampere, it also has direction. Even though it has magnitude and direction. It does not obey vector laws of addition. Therefore, it is not a vector quantity. For example, if you say 5 ampere flows from here and 5 ampere flows from here, imagine if this was a vector quantity, shouldn't the current become 0? But we observe the current is actually 10 ampere. Got it? So vector loss meaning it should add like vectors also. Current does not add like vectors. Now, the kind of questions I'll ask you on this. Let's start with a simple thing. A charged particle Q goes in a circle with constant speed U. Find the average current. Remember this thing, huh? This will again come in magnetism in modern physics. A charge Q, I'll tell you how it comes, moves in a circle with constant speed U. Find the average current. Remember, I just taught you one definition, I is dq by dt, and you can play a lot with that. Let's see. This question, you know how they'll ask in the exam? An electron is going in a hydrogen-like atom. Find the current of an electron in the nth orbit. An electron going in a circle is like a charge flowing, right? So that entire loop will act like current. And because of that current, you get a magnetic field. Isn't that what we call as principal quantum numbers? NLM, M is a magnetic quantum number. You can actually, these things actually generate magnetic field. That is what results in paramagnetic and diamagnetic materials. Did you heard about these terms, paramagnetic and diamagnetic? So later on, we will see. Actually, you can explain all that stuff because of the motion of electrons in the orbits. Get this thing? Easy. A charged particle is going in a circle with speed U. So it is like a charge is flowing, you know, so there's like a current. So find the average current. Everyone should start solving capacitors. Do finish it off, you know, keep this Saturday as a deadline and try to work it out, or at least next Wednesday maximum. And the test is extended till Thursday night, that is till tomorrow night. I hope everyone will be able to give it properties of matter. And I'll upload one more practice paper on properties of matter. That won't be graded, but there'll be an additional practice paper next week. So someone who wants to do an additional practice, you can give that paper. And do start solving capacitors, because next test is electrostatics, Gauss law and capacitors का advanced test. So capacitors है उसमें, so do prepare. The test will be online on Friday. I'll give you time till next Thursday. Told you this multiple times. Here I'm telling you, entire electromagnetism, modern physics, wave and wave optics, itna baki hai portion. This much is almost 45 to 50% weightage. If you focus on these chapters, once the portion gets over by November mid, that last 1.5 months, I'll be taking up few topics for your 11th standard ka rotation, units and dimensions and errors, center of mass collision. Thoda, these topics I will revise again. So mechanics, thoda important topics I'll revise. So that way, that's what I'm saying. These chapters we won't get time to revise again. So please make sure to do them properly. First mains mein our target should be like out of 100, we need to cross at least 75 in physics. And which is quite doable score. 75, 80 is quite doable score. Paper will be quite easy. If you compare like last 3 years, maths paper is going to be tough. So if you can put maths mein 40, physics mein 70, chemistry mein 60, will around be 170. You will put 98 plus percentile. And most people will mess up the first mains paper. Because सबको क्या लगता पता है, अरे boards है तो मैं कैसा prepare करूं. After the boards I'll prepare well and give the second mains. And that is the reason even the second mains when you score more, your rank is still bad. You should definitely take advantage of this and prepare well for the first mains. And you need to balance your subject. How to do this? Simple thing, no? What is I average? Total charge by time. How much charge is flowing? Q. What is the time? Time taken for one revolution is 2 pi r by u. So Q u by 2 pi r. Bas. Right, Labdi, you got it. Easy? You ping me in WhatsApp now, Vrinda, I'll send you. You want any other additional paper other than what I'm keeping, you can just ping me in WhatsApp. You will get it in a day. But just make sure not the recent papers. So those to anyway are there in the group. Next one. We have a charged ring. Rotating with omega. Charged ring of linear density omega. Linear density lambda. Rotating with omega. To find the current. So we have a charged ring of linear charge density lambda and radius r is rotating with omega. Find the current. This is 1b. Try. This is a proton beam. Any answer? How do we approach this? See, first one. What is current? Charge by time. What is charge? Lambda into 2 pi r. What is time? 2 pi by omega. Lambda r omega. Easy? Yeah, right, Kavish. बस इतना ही करना था, charge by time, nothing else. Look at the C part. You have a proton beam traveling with speed v. Area of cross section is A and n is the number of protons per unit volume. Find the current. So if you send a group of protons moving forward, that's like a current. So, and this C is important result, right, which you need to remember. We're going to use it later on. If a proton beam is traveling with speed v, area is A, n is the number of protons per unit volume. Charge is, you can take it as E. Find the current. I'll give you a minute. Everyone should give it a try.
Sir, NA.
And maybe into E करना पड़ेगा. शौर्य. चार्ज भी लेना पड़ेगा ना.
हाँ.
Show you. See. So we have a proton beam going with V. So, and you have a charged particles here everywhere. Consider a small cross section. So what is the small volume? A into dx. What is the number of protons in dx? N into A into dx. So what is the charge in the dx? Number of protons N into A into dx into E, na? Right, Labdi? Current dq will be dq by dt, which will be N dx by dt, which is nothing but NEAV. That's your formula. So NEAV. V is the velocity, E is the charge, A is the area of cross section, and N is the number of this thing. So suppose if someone asks you like this, we have ions here. Let's say this is Fe2 plus ions. Let's say helium nuclei, better. And these are electrons. Let's say the speed is v by 2. The speed is v. And let's say this is n, and this is n. Find the total current in the region. How will you do this? We have alpha particles going to the right side and electrons going to the left side. N is the number of particles per unit volume. Speed is v by 2 and v.
2 NAeV.
Try. Type your answer, no, Shaurya. Let others also try. Type here in the co-host. I hope this question is clear. It is exactly the CEGA question. I just added one more thing. Try. I'll give you a minute. See. Just changes the green color. So the helium is a positive charge, which is going right side. The current due to this helium will be N. Charge will be 2E. Remember, charge is 2 plus it is. 2E, area is A, velocity is 2. Electrons are going to the left, so the current will be to the right. So current due to the electrons will be NEAV. So the total current will be, just add them, 2 NEAV. Current will be opposite to the flow of electrons. This would be opposite to electron flow. So both will add up in the same direction. And remember, helium 2 plus it is. So the charged particles ka charge is 2E. Getting this, everyone? Check it out. Next one. Any
Sir, in this case of the electrons का flow अगर उल्टा होता तब
then
minus
subtract
करते
हो
क्या?
जाएगा. Yeah.
Sir,
Subtract हो
you
जाएगा.
told current is not vector quantity. We can't means it will add only.
हाँ, मैंने कब बोला वेक्टर्स में ऐड हो रहे हैं? वेक्टर में like this they'll add like 2i cos theta. I1 plus I2 तो होगा ना?
Okay.
That way. It's like if I add 3 apples plus 2 apples, how much ratio हो गया?
5.
But वेक्टर तो नहीं है. ठीक है? Vectors meaning the directions and angles and stuff. Next thing, if I want to ask you this question little tougher. So this is grounded. This is a hollow conducting shell. Radius r. From the center at a distance, we have a particle, charged particle plus q traveling with speed u. Tell me one thing, as the charge is coming closer, won't the charges be induced more and more? So if the charge is coming more and more, let's say here we have an ammeter. What does an ammeter do? Ammeter measures current. So this distance is d. Find the current in the ammeter at this instant. A charge q moves towards the center of the shell. With speed u. Find current at this instant. So as you're getting closer to the shell, you'll induce more and more charge. When charge is flowing from the earth to the shell or something is happening, the charge will flow through the ammeter. What is the current in the ammeter? Gauss law and current electricity. Whenever you ground a shell, what is the potential?
0.
0. Remember that. Whenever you ground something, potential is 0. Now, how do you approach this? Try. Viksha, your camera has become blank. Right? See if you can do something about it. How do you approach this? See, the problem is what we don't know how much charge is flowing, right? Tell me one thing, when you say I'm grounding something and the potential is 0, what does it mean? Potential is 0 to whom? Let's say if this charge is Q, and let's say this is Q dash is your induced charge. Q dash is your induced charge. So when you say potential is 0, it is 0 due to whom? Due to everyone, isn't it? Due to this Q dash and due to this Q. Together it is 0, no? And let this distance be X. So potential at the center of the shell will be KQ by X, the point charge, plus KQ dash by R. Now one thing, see, the Q dash is non-uniform, but all the charges are at equidistant, isn't it? Even though the charge is non-uniform, all the charges are at equidistant from the center. And potential is a scalar quantity. You can directly take KQ dash by R. This is equal to 0. So we get Q dash is equal to minus QR by X. So what is current? So whenever this current flows, which charge will change? Q dash, right? Does everyone agree with that? Whenever the current I flows, which charge will change? Q dash will change. So current I is equal to dQ dash by dt. So this will be minus QR d by dt of 1 by x. So that would be minus QR minus 1 by x square dx by dt. So this would be QR by x square. And what is dx by dt? What is dx by dt?
U.
Minus u because x is decreasing. Be careful with that. X is decreasing here. Dx by dt is minus u since x decreases. And then you're done. So you want current here. This is the current as function of x. Since you want current at distance d, so I is equal to minus QRU by d square. What is the meaning of minus sign? I thought current is coming from the earth to the shell, but actually current is going from shell to the earth. There is a meaning of minus. The direction we assumed is wrong. Negative indicates current is flowing from shell to earth. We assumed reverse. Current is going from shell to earth. Please check. It's a good one. So the idea here is when a charge Q is there at a distance x, it will induce some charge Q dash such that Q and Q dash ka dono ka potential 0 the center pe. From there you got the induced charge and then you differentiated dQ dash by dt. Check.
सर बट हमने अज्यूम कहाँ पे किया कि वो अर्थ से शेल में गया
क्या?
करंट
What you're talking about? Yeah.
Sir, I'm asking ki where did we assume that the current is going from the earth to the shell? No, in the form means in the calculations.
Yeah, the I का direction देख रहे God. You take it from where to where? Earth to shell ना इसीलिए ना you wrote I is dQ dash by dt. The rate of change of charge is current. So this charge is changing. So your thought Q dash was increasing. Yeah. All got this thing? Great. Next one. So let's say we have a capacitor, square plate side A. This is connected to a battery with an ammeter. Voltage V, the distance is D. Here we have a dielectric slab of exactly the same width. This side is also A. Dielectric constant is K, and it is going with speed U inside. You're getting what is happening? The slab is being pushed inside slowly. A dielectric slab enters the capacitor with speed U. Tell me one thing, if the capacitor goes inside, dielectric goes inside, what will happen to the capacitance? Increase or decrease? Anyone? If you put a dielectric inside a capacitor, what happens to the capacitance?
Sir, becomes
Increase, right? So if the capacitance increases, what will happen to the charge? Increase. If the charge is increasing, doesn't it mean there's a current flowing? As the slab is going inside, C is continuously increasing. So Q is continuously increasing, meaning the battery has to provide continuous current. Find the current. Are you getting why there will be a current? If the slab is going inside, C will increase. If C increases, Q is equal to CV, Q will increase. If Q increases, there will be a current because rate of change of charge is current. Try capacitors and current electricity. And Roma, I just taught you one definition, I is dq by dt. Think. How do you approach this? Anamai, so far clear? Logic is clear, na? Divanshu? Clear? Divanshu? Got this? Vrinda, idea is clear? Try. 2-3 minutes, everyone. This question and the last one, these are the kind of questions you can expect in advance. How do you approach this? You have done something similar like this. Can you do this for me? Let's say this is what it has gone inside. So let's say the dielectric slab has gone till here. Let's say it has entered X inside. So what will be the remaining distance here? A minus X. And this distance is D. Can you find the capacitance of this? Let the slab enter by X. Can you find the capacitance of this? We have done this in capacitors, if you remember. If you have revised the notes, you would have observed this. Didn't we do this? Same thing, no? X has entered inside. Remember this logic? It was the exact same question. Try, I'll give you a minute. Find C equivalent here as a function of X. How do you do these kind of things? This can be treated as two capacitors, isn't it? And both are in parallel. So this is one capacitor and this is a normal capacitor. So this capacitor ka formula will be, area will be how much? This is A into X epsilon K times by D. That's your C1. C2 will be A minus X into A epsilon by D. This is your C2. So C equivalent will be C1 plus C2, which is A epsilon by D into Kx plus A minus X. That's your C equivalent, everyone. Please check. A epsilon by D, you take out X common, so K minus 1 plus A. You're done. Basically, what is charge then? Q is equal to C equivalent into V. What is current? dq by dt. So if I differentiate this, I get A epsilon B by D. And when you differentiate, you get K minus 1 into dx by dt. And dx by dt is nothing but U. A epsilon B is the voltage by D into K minus 1 into U. But there's a small catch here. Current is constant. If you observe, it's a constant current. Please check what I did. Let me show you something. There's a small trap here. Exam mein they'll ask you plot current versus time graph. Everyone do keep your cams on. I'll start removing you guys from the group. If you switch off with a random reason, if you're having dinner, you have to message me, and you can't eat dinner for 1 hour, 45 minutes. Finish it off. 5-10 minutes acceptable. You're eating for 1 hour, then this will become like a movie show with a popcorn. Don't do that. Next one. Now, what is the catch here? Listen, the catch is when the slab is entering, this is T is equal to 0. Agreed? So when you're entering here, what happens? Capacitance increases. Therefore, Q increases. Therefore, I is positive. And then what will happen? At one point, it has completely gone inside. At this time, the time is A by U. After this, the slab will start coming out. At this time, what happens? Charge is decreasing. Means current is decreasing. Charge is going back into the battery. Till when? Till T is equal to 2A by U. So if you actually plot this graph, current versus time, the current is constant, but aisa hoga. Current is constant till A by U. Then the current becomes negative for 2A by U, and then the current becomes 0. This is the catch. The current goes into the battery for some time, then the current comes out of the battery for some time. You're getting it? Current will reverse direction. So initially current will flow like this when it is entering. Once it is leaving, current will actually reverse sign. This is the important thing. So most people think current constant, but they forget this part. So current reverses direction when the slab is coming out. Be careful. If they ask you a graph, this is what you do. Magnitude is constant, but the direction reverses. Is that making sense, everyone? Because as the slab is entering, Q increases. So I is positive, meaning capacitor is getting charged. When the slab is going outside, C decreases, meaning charge on the capacitor is decreasing. Matlab current ka direction reverse ho gaya na? Current is leaving the capacitor and going into the battery now. I hope that is making sense, everyone. Please check. If you see, these are one type of problems. Basics of I is dq by dt. Just with the definition, you can play around like this. Do check. Anyone has a doubt on this, please ask.
Current will be independent of that X.
Yeah, independent of x. Clear? Can I turn the page? Trisha, Asni, clear? Vrinda, Kavya, got this? Chirayu, clear? Reina? Nishita, Labdi? Great. Next thing, current density. The symbol is J bar. So the current density definition is J is current by the area perpendicular. We can also write this thing as I is equal to J bar dot A bar. Even though current is not a scalar quantity, current density is a vector quantity. So basically current density is defined as current flow per unit perpendicular area. The direction of J bar is the direction of the current. And it is a vector quantity. This we're going to use in magnetism again. So if you have taken a cross section like this, and let's say this is the current I. So for this area vector is this way, J bar is this way, and this is theta. So we can simply write current I is equal to J bar dot A bar, which is JA cos theta. A is the area of that shaded part. It's not the cross section, it is the shaded part area. So simply current density is I into area. Have a look at this. Clear? All got this? Let's see a question on this. Let's say we have a cylinder of radius r whose current density solid cylinder with current density J bar is equal to J naught into small r. Small r is r to 0, meaning it is not constant. When r is 0, current density is 0. As r is increasing, you're getting more and more current. Meaning this is how it looks. So in the center, current is 0, then it increases a bit, then increases more, and there is more current. You're getting how it is? As you go away from the center, current is flowing more on the outside compared to the inside. So it is changing radially. Find the total current in the wire. Find current in the cylinder. Get this. Remember, J is simply current by area, but the problem here at every instant it is changing. You have to integrate. Try. You got 1.5 minutes, 2 minutes.
Sir, above you showed the direction of that area.
Come again.
Above the rays you showed for that J naught. No?
J naught, J naught. J naught by R cubed by 3. How do you choose an element here? This is what you do now. At a distance x, we take a thin sheet. So current in that small sheet will be J into area, dA. This will be small current. J will be J naught into x, area will be 2 pi x into dx, the circumference. Isn't it? That ring ka area, na? dA is the area of that ring. So you're taking a ring of x radius and thickness dx. So the total current will be 2 pi J naught integral x square dx, which goes from 0 to r, which is 2 pi J naught r cube by 3. Check. Clear? Easy? Any doubts on this? Next one. Danya, clear with this? Kavish? Amu, got this? Rishi, clear so far? Perfect. Next thing. A little bit of a theory. How does this electrons move inside a conductor? Motion of free electrons in the conductor. Inside a conductor. So let's say we have a conductor here, and if you just look at the electrons inside, the electrons are simply moving randomly, completely random motion. So electron moves randomly with high speeds due to collisions with the other electrons. So basically every time it goes, it will start colliding. So therefore the average velocity is 0. Because if the what you call the displacement becomes 0, if the randomly it is going, end of that it will come back to the same position. Therefore the average velocity is 0. Now if you look at this kind of motion, right, it's called random motion. And if you look at the speed of this random molecules, we know kinetic energy from thermodynamics is 3/2 kT, Boltzmann constant, which is equal to half into mass of electron into V. We call it V thermal square. This speed is coming because of temperature. When you calculate this V thermal speed is in the range of 10 power 5 to 10 power 6 meters per second. the electrons go pretty fast, 10 power 5 to 10 power 6 meters per second. But the problem is what? These are actually useless. They don't help you in any current, because the average becomes always zero. They're not responsible for any current flow. But the same thing, if you take the conductor of length L, and let's say you connect a battery here of voltage V, we get here inside the electric field. We know the electric field is what? Potential difference by distance between them, V by L. So this will establish a field inside here. And because of which the electrons will go opposite to the field, because it's a negative charge. Here we are neglecting random motion. Huh? If you neglect the random motion, and if you apply a battery, we observe all the electrons will simply move around. This will result in something called a systematic motion. Something like this we have seen in thermodynamics. It is in. This is what is responsible for current, the systematic motion. So whenever you put a battery, if you combine both of them, the net motion will be like this. The actual motion of an electron with the battery it's going randomly, it goes forward, randomly, it goes this way, it goes randomly, it goes here, it goes randomly. There is a net motion here. Electron eventually, right, keeps on going forward. So it is actually a combination of random plus systematic motion. So electrons are actually moving like this. They're always going forward, but they're always, colliding with each other. Is this making sense, everyone? So this thing, right? I think it was taught in, I don't remember the chapter. I think it was taught in chemistry where there is a concept like this. So when I was in 11th, I was unable to understand this exactly what is happening. Then my friend Sabir, he used to help me a lot. So Sabir that day, and normally we used to go in the bus every day evening, 45 minutes while going. So Sabir used to explain me all my doubts in the bus only. So that is the only time he was free, or else he was a very busy guy. So this guy, he told me like, I said, yeah, random motion, systematic motion combination, exactly hota kya hai? Then what he told me is that, Arun, imagine this Ganapati ka procession. Visarjan hota hai na? So if you take this, this Ganapati ka procession, as the god is moving, if you observe the people surrounding the god, they're just jumping, dancing, howling, they're doing anything. You can't predict what this guy is going to do next moment, isn't it? The motion is completely random. They're pushing each other, they're colliding with each other and everything. But the moment the god goes from here to here, the randomness also goes with them, isn't it? So if you see, the speed of the procession is very slow. The speed of each person is very high. But end of the day, if I ask you how much did this person go, it is equal to the distance moved by the god, right? You get the point? What causes the displacement is not your individual velocity, but the speed of the whole procession. Are you getting this point? So this is how it looks. So whenever it's a systematic plus random motion, imagine a Ganapati Visarjan ka procession, right? People are dancing around and jumping. That's your random motion. And the procession speed is your systematic motion. Is that making clear, everyone? So if you try to find the acceleration will be the field into charge by mass m. And we know E is equal to V by L. And from here we can substitute, this ends up to be VE by ML. This is the acceleration of the electron. We define something called tau. We have done this in KTG. Anyone remembers what is relaxation time?
Time between consecutive collisions.
Yeah, average time interval between two collisions. Between consecutive collisions. This is the average time between two collisions, consecutive collisions. So we define this tau is nothing but the average mean free path by V thermal. So mean free path, this also we defined in KTG. This is the average distance traveled between two collisions. So if you look at here, tau is proportional to 1 by V thermal. So if you increase temperature, the temperature increases, speed increases. Therefore, tau decreases, meaning we'll have more and more collisions. Because you're going so fast, you'll collide in much smaller time intervals. So keep that in mind. Now, if you try to calculate the average velocity, V average will be displacement by tau. Displacement is half a tau square by tau, which turns out to be a tau by 2. This is your average speed. This is also called as drift velocity. This is responsible for the current flow, systematic motion. Because of this electric field, all the electrons will gain a horizontal velocity. They're moving slowly. That velocity is this. This is the responsible for current flow. And the value of the drift velocity is quite small, 0.1 to 1 centimeter per second. Do have a look at this.
So how do we get displacement?
S is ut plus rpt square. Use 0, no? ठीक है?
Sir, conductor के end में velocity 0 होगा क्या?
What?
Conductor के end में velocity 0 होगा.
Conductor end में, this is the U is the electron का speed record.
हाँ, वही that I will asking V0 होगा क्या मतलब?
This is the thermal speeds we are talking, so it's almost 0. After collision, you stop, right?
Oh.
All clear with this? Again, now this derivation is not that important, but let's see where it will this lead to. But do have a look at this. Ask me if there's any confusion here. So let me just complete this. So we get V drift is a tau by 2. And what is A? A is this thing, VE by ml. Tau by 2. And we know current I is equal to NEAV drift. We just solved it today in problem 1C. So from there we get current is equal to NEAV drift will be VE tau by 2 ml. This can be written as NE square tau by 2 m A by L into voltage. So this can be written as V is equal to I into 2m by N E square tau L by area. This is what we write as V is equal to I into R. Ohm's law. So we get resistance is equal to rho into L by area, where rho is given by 2 into mass by N into E square tau, resistivity. We define sigma, which is nothing but 1 by rho. It's called conductivity. So if you look at this formula here, so V is equal to I into rho L by area. This is where we get that V is equal to IR from. But remember, I is proportional to V. This is Ohm's law. V is equal to IR is not Ohm's law. The current is proportional to voltage. Voltage does not depend on current. Current depends on voltage. The most important thing here, when you write rho, which is rho L by area, L is what? We have done in thermal resistance. Length along the current flow. You can't take any length you want. What is a area perpendicular to the current flow? Now in this, the important ones to remember are this one, this one, this one. These are the three important ones. They really, they never asked anything on this row actually. You know how they can ask questions on this? In a hypothetical element, the charge of an electron becomes double. Then what will happen to the resistivity? Two square na denominator mein. If the charge of electron becomes double, this is E square. Rho becomes 1/4. So resistance becomes 1/4. Are you getting this? Do have a look at this. So all the story, right? Systematic random motion. From there, we end of the day, we got this Ohm's law I proportional to V. Do have a look at this page once, see what we did, and then I'll turn the page again.
सर जो रिलैक्सेशन टाइम का जो फॉर्मूला केटीजी में पढ़ा था उसमें वी मेन की जगह वी थर्मल डालेंगे तो नहीं चलेगा क्या?
अरे भाई वी थर्मल क्यों डालोगे? अरे दिस derived for gas molecules there.
ओके
Have a look at this page. See, next thing. So, here are some important points here. If temperature increases, tau decreases, therefore rho increases. What is rho? 2m by n e square tau. So, this was asked in a, I think, bits or CET, I don't remember. But it's a good one. They did have something like this. For conductors, resistance decreases with increase in temperature. Sorry, resistance increases with increase in temperature. If you increase the temperature, the electrons will collide more and more, so it will be more difficult for them to flow. If you increase the temperature, resistance increases. For semiconductors, something else happens. For semiconductors, it is not about the flow. The resistance actually decreases. And the reason is, since the number of free electrons are less, in case of a conductor, you have a lot of free electrons working. This n in the denominator is pretty big for conductors. But for semiconductors, the n is very small. So when you increase the temperature, n increases drastically. When temperature increases, more and more electrons come out of the lattice. Increasing n. So n actually dominates. So even though the tau is decreasing, this dominates. So be careful. Exam will ask a question like this. With increase in temperature, what happens to the resistance of a silicon? What will happen? Silicon is what?
Semiconductor.
Semiconductor. So if increase the temperature, silicon का resistance क्या होगा? Decrease. If they say copper wire, if the increase in temperature, resistance of copper wire
Increase.
increases. Can you tell me somewhere we have done something like this? With increase in temperature for one material, it increases, one material, it decreases. What is that property? कहाँ पे क्या हो? Similar like that. Different materials, when you increase temperature, one material, it increases, one material, it decreases. Which property is that and what is that? Anyone remember? Perfect, Hassan. Viscosity. Remember, viscosity of liquids decreases with increase in temperature. But for gases, it increases. Because in case of liquids, viscosity of the liquids decrease with increase in temperature. Viscosity of gases increase. Yaad hai? Don't forget this. Reason we wrote bond distance decreases, yahan pe collisions will increase. There. So we have rho is equal to rho naught into 1 plus alpha delta T. This is how the resistivity changes. Rho naught is the resistivity at 0 degrees. Alpha is the coefficient of resistivity. Alpha is positive for conductors. And negative for semiconductors. Keep that in mind. Clear? That is one thing. So theoretical question there. Kavish, clear so far? Maika? Ishita? Great. Turn in the page. So I is given by NE square. We have just derived that I value from here. This thing NE by 2m A by LB. NE square tau by 2m A by LV. So I can just shift here I by A and I can write this as V by, and this guy becomes NE square tau by 2m. This is nothing but current density and V by L is field, and this becomes 1 by rho, which can be written as sigma E. This is an important formula. J is equal to sigma E. Sigma is conductivity. That means whenever a current flows in a conductor, right, there is an electric field in the region. This is one important thing. If you remember in Gauss law, we studied this statement. E inside a conductor is 0. Due to charge distributions, we wrote this statement. But if there's a battery, field need not be 0. Static charge distribution meaning charges are not moving. But in case of a battery is a little special. It keeps on messing up the field. But need not be 0 when there is a battery. So be careful. Ye true and false statements mein aayega. The field inside a conductor is always 0. Not true. The field inside a conductor need not be 0 in case of a battery. But if they say the field inside a conductor is due to static charge distributions, it is always 0. You know why is this happening? I'll just give a crude example, see what is happening. Remember this story? Let's say there are 2 rooms. and you're standing here and you're throwing people from one room to another room. You remember the story in Gauss law, charge distribution? So let's say initially यहाँ पे 100 है, यहाँ पे 100 है. So let's say if you throw 20 people here, this becomes, let's say 70 and this becomes 130. So if you're trying to push them, what will happen? They will try to resist you. If you keep on pushing more and more people, let's say this becomes 30 and this becomes 170, what will happen? The resistance will become so high, the charge will stop flowing, isn't it? This is the reason why field was 0. Agreed? But what happens? Imagine there is actually a hidden door from this room to this room. No one knows that. Abhi baat kya hoga? When you put people here, won't these people start coming back in this room? You're continuously trying to push here and these are continuously trying to come back here. Do you think any time will these two cancel out? This green one and the red one, will they cancel out? They'll not cancel out, right? That's why the field will never become 0. Are you getting the logic there? The moment the current starts flowing, you're not giving time for the charges to accumulate and create an induced field. Every time there is a pressure here, what will happen? The people will simply come back to this room, right? That is what is happening. So, but anyway, that is one thing. I'll just summarize all the formulas we have done. You can note it down. We'll do questions based on that. So first thing, I is proportional to V is Ohm's law. Remember, don't write V is equal to IR. So from there, we get the proportionality constant, V is equal to IR. So anything that obeys this formula are called ohmic conductors. Every material need not obey this. J is equal to sigma E or 1 by rho E. R is equal to rho L by area. I is EA V drift. Rho is equal to 2m by NE square tau, which is also equal to 1 by sigma conductivity. Rho is equal to rho naught into 1 plus alpha delta T. That is the change in temperature के साथ resistance. और क्या था? J is equal to I by A perpendicular current density. Yeah, these are all the formulas. Yes, you can note it down. We'll do some problems on that. Do check. So that's a bit of a theory. All clear with this? Harish, Shaurya, people were saying after the party while going, doing all weird stunts in the train, it seems. क्या कर रहा था तू?
Or at the metro station only was fooling around.
क्या हो गया? स्वीट ज्यादा खा लिया क्या? शुगर है?
अरे
अरे
सर on
नहीं,
the opposite
नहीं
platform
सर,
में
अरे
dance.
सर कुछ लोग गाना गा रहे थे तो मैं भी उनके साथ गाना गाने लगा बस.
That I don't know. People were saying everyone in the metro is looking at you only. You're doing something weird, jumping around and all. ठीक है. Your juniors are like, sir, we are getting a sugar high, but we will eat this one cake. So let's see some questions. It was good, right? Seeing you all. अच्छा लगा था. It was nice, na? Also, space was there. We literally occupied that whole restaurant, I guess. Let's see some questions. Get these things. Let's get them. Just give them. Just give me a minute. I'll be just back in 2 minutes. Yeah. What is the answer for the first one? See, first thing is what in a wire of cross section R, free electrons travel with the drift velocity v, current I flows through the wire, and the current of the radius of the same material. So basically, I is equal to NEAV drift. So you're saying, and the area is how much? Pi R square. So this is actually equal to, you said same material, na? Same material, matlab N will be same. So area is proportional to R square into velocity. R became half, so 1/4 tha. V became double. So that is half na current I by 2. Make sense? Got the logic what we did simply there. I is proportional to R square into velocity. Velocity is double and V is 1 by 4. Sixth one, just how I told you, resistivity of a semiconductor decreases with increase in temperature. True. In a conducting solid, the rate of collision between fluid and ions increases in temperature. That is also true, and both are true. Clear? Semiconductor, why does the resistivity decrease? Because of more free electrons. The reasoning is different. Collision का reason नहीं था. It is because of more free electrons. What about C? Keep going. C is the D question we did 1D. Similar wala tha. Try. There is a chocolate fountain, it seems. Did you guys see that? मुझे दिखा नहीं. I was searching for it for so long. किसी को मिला था actually. It was there near the kitchen, it seems. It was hidden behind. That idiot came and told me at 9:30. अब जाने के बाद. There was a chocolate fountain. Shit, na? I know. I was telling you also, na? अरे chocolate fountain था करके I was telling. Idiots, they also hid it. युषा करके है वो दूसरा बात. वो जाके खा रहा था secretly without telling anyone. People are so selfish. I didn't get to eat the mango cake. खत्म हो गया था. The best thing, one guy came to me and said, "Sir, can I eat everything here?" I said, "हाँ, eat everything. What is the problem?" मतलब I'm not understanding what to eat. I said, "सब खा लो एक बार उसमें क्या? I'll be more than happy." It was nice. We'll again meet next year. I'll call you every year. Do come. What about the seventh one? An insulating pipe of see now what is happening here. The 2e charged particles, let's say, are going this way. See what happens whenever you apply now 2 plates, like we said, cathode and anode. This was the anode and this was the cathode. So your anode is your positive charge, cathode is your negative charge. So when you put this positive charge here 2e, they actually go this way. And when you put the negative charge E, they go this way. So actually currents will add up here. Currents will add up here. So the current due to the 2E will be N is same, E and 2E, area, and the velocity is V by 4. I for E will be N E A V. If you add the total current, it will be 3 by 2 N E A V. D is the answer. You have to add the current, everyone, because the positive and the negative charges will go in the opposite direction. Please check 7th one. It's a good one. Clear? Any doubts on this thing? 6, 5, 6, 7. Turn in the page. All clear? These are good ones, right? How do you do these two? Try 2 minutes.
C.
First was easy. So what is same for both of them? I is equal to NEAV drift. So A into V is constant, just like equation of continuity. A1 V1 is equal to A2 V2. So if area is small, speed is more. So if you look at the area, P may area is small, Q may area is big. So VP is greater than VQ. Make sense? Smaller the area, faster the electrons will go. Just like equation of continuity. 9th is a good one, right? Karo 9th one, it's a good one.
That 9th multi-correct है कि single correct?
Shaurya, you can type your answers in the chat box. Let others also try, na? We know that you know and you're a good singer. People were praising you in that offline batch. Sir, Shaurya was dancing and pura metro dekh raha tha. He was the star of the metro types. पता नहीं तू क्या किया, but I told them should have recorded it. Viral हो जाता था पूरा. Ninth one. Multiple answer था Shaurya, right only. कर, तेरा multiple answers. Read the question. Try. I'll give you 1.5 minutes. Brinda thinks all are right. Chalo, let's see. See, let's see each one, okay? The current at the cross section P is equal to the current at the cross section Q, meaning he's saying if you take this full cross section and this full cross section, current is same, right? Because current is simply the flow of charge. Number of electrons flowing through P should be equal to number of electrons flowing through Q. Does it make sense? The total current is same. The first option is right. The electric field intensity at P is less than or equal to Q. We know the formula J is equal to sigma E. J is nothing but current density by area. So we get E is proportional to 1 by area. So if the area is small, field is more. So second option is also right. Is this making sense? J is equal to sigma E. J is I by area. So E is proportional to this thing. Since area at P is greater than area at Q, so field at P is less than field at Q. The third one, the rate of heat generated. Now this is slightly little different. We know the heat curve formula is I square R into time. And we know resistance is equal to rho L by area. So if area is small, R is big. If R is big, more heat will be produced. So the rate of heat generated per unit time at Q, because Q by area is small, R is more. So that is also right. Make sense? This is what actually happens in bulb ka filaments. By chance, in a filament, if the bulb becomes thin, the resistance becomes high. So heat produced will be more. So temperature will be more. So the filament will become even more thin. If it becomes more thin, it will generate even more heat, so it will eventually break. So this is one of the reasons, right? Whenever you make bulk of filaments or anything with a heater element, they should have uniform cross-section area. By chance, if you make somewhere little thin, you're gone. That joint will break eventually. Clear? The joint will produce more heat compared to the surroundings. It will eventually melt. The number of electrons crossing per unit area. Now this is different. See, total number of electrons are same, but per unit area it is different. Total electrons is same, but if you divide per area, area P is bigger. So, but electrons per unit area is different. You have to divide by area because P ka area is more. D is also right. All four are right, everyone. It's a good question. Please check it out. Option A, the current at cross section P. Current is what, Ray? Amu? Total charge per unit time, right? So P में कितना charge flow करेगा? Same charge will flow through Q also, na? Charge conservation. Where will the extra charge come from? Total number of electrons entering per second should be equal to number of electrons leaving per second. Junction law. Only difference क्या है ना? It is like water का flow, na? There will be speed will be less, here speed will be more, but the total water is constant. Please check the ninth one. It's a good one. All clear with this? Next one is a good one. Easy one, but a good one. It's an advanced question. Let's say we have a wire made of two different materials. Rho 1, rho 2. This is an interface. We call this thing a composite wire, meaning you took an aluminum wire and you took a copper wire and you joined them. Such a thing is called a composite wire. A composite wire is made of two materials. And the current flowing through this thing is I. Find the charge at the interface. So because of this, there'll be interface. How do you approach this? Now, if you think about it, why this is happening, simple logic, I'll tell you. Let's say you have a Mumbai-Pune expressway. Beautiful road, 4-lane highway, pretty fast to go. Once the expressway gets over, this thing whole converges into 2-lane. This is what happened, with this Mumbai ka Sea Link. These people spent so much money, they constructed Mumbai ka Sea Link with that, 5 to 6 lanes. Sab super tha, but problem ye tha, the exit, right, goes into a 2-lane ka road. So on the Mumbai Sea Link, right, you travel very fast, zoom, you travel. Sabko lagta hai you save time. You'll come here and get stuck, isn't it? So that is how things are planned. So that is how always it is. People, is what you're simply doing, right? In a city like Mumbai, if this is your Mumbai, right? You think there's a lot of traffic here, you build a bridge. You simply shifted the traffic from here to here. So you're just shifting the traffic towards north. You're not actually decreasing the traffic. So yeah, welcome to life. That is how it is. So what happens? So imagine that. So you have a super highway there and suddenly it becomes a normal kacha road. All the cars will get stuck here, isn't it? That is same as your electrons will get stuck here, no? Charge will get accumulated at the interface. Because one side it is conducting, one side it is not that good conductor. So charge will accumulate. How will you find this? Think for a minute, then I'll show you.
Sir, can you show previous pages? Yes, sir.
Do start solving capacitors because current density will finish off in 2 weeks. Listen, what is happening here? The solution is pretty novel actually. When you have the interface here, we know the current is equal to J is equal to sigma E or E by rho. Now, both the sides rho is different. So E is equal to rho into J. J is nothing but current by area. So this side, the field will be E1. This side, the field will be E2. So field is not same on both the sides. Consider a Gaussian surface. So the flux through the Gaussian surface will be E2 into area, the field is going out, minus E1 into area, the field is entering, isn't it? This is the total flux. What is total flux equal to? Charge enclosed by epsilon. Meaning because of this, we will get whatever charge is accumulated on the interface, we can calculate that value. So this thing turns out to be charge enclosed. It will be epsilon into E2 minus E1 into area. What is E2 minus A1? Epsilon rho 1 minus rho 2 minus rho 1 by I by area. Area cancels off. Answer is epsilon into I into rho 2 minus rho 1. Check, that's your answer. So the idea is you have to use Gauss law. Basically, using J is equal to sigma E, find field, from field use Gauss law, and from there you finish it off. Do check it out. Clear with this? Next one. So that this is one part till here. This is all the theory and little, theoretical problems and basic stuff. Turn in the page. Combination of resistors. Just be careful, resistors and capacitors, the formulas are reverse. Resistors in series. When do you say two resistors are in series? They should have same current and same branch. Be careful, just because they're side by side doesn't mean they're in series. So R1, R2, current I is same. You can replace this with R equivalent. We get R equivalent is R1 plus R2. And we get the voltage V1 is I into R1, V2 is I into R2. So V1 by V2 will be R1 by R2. The voltage will divide in the ratio of resistances. Parallel, same potential difference. R1, R2, 1 by R equivalent is 1 by R1 plus 1 by R2. So we get R equivalent is R1 R2 by R1 plus R2. If you take this current to be I, and if this current splits into I1 and current splits into I2, I1 by I2 will be in the ratio of opposite resistances. More resistance, less current will flow. And then we have your Wheatstone bridge. I'm just writing down everything here. Standard stuff. This is the third time, fourth time we are seeing this already. Heat transfer, viscosity, capacitors, and this is the current electricity. So this is R1, R2, R3, and this is R4. This is R5. So you can circuit becomes like this if this ratio is balanced. R1 by R3 is equal to R2 by R4. Check this out. This is the standard stuff which I've done already. Let's see some questions. Questions will be quite similar to heat transfer, bit of them. Let's say a question. I hope this page was clear. Standard thing. Let's say we have a cuboid. This is A. This is B. And this is C. So this is phase 1, phase 2, phase 3, phase 4, phase 5, and phase 6 is PJ. Find, so if you connect the battery, resistance between 1 and 2 means if you put the terminals between 1 and 2, between 3 and 4, and between 5 and 6. Get the ratio. And diagram would look like this. 1 and 2 meaning you're connecting between these two phases. Between 2 and between 1. The battery is between these two terminals. 3, 4 meaning that is 3 and this is 4. 5 and 6 meaning the front and back. Find the ratio of resistance if the battery is connected with like this. Get this, it's a good one. Remember the formula, rho L by A, what is L and what is A? See now, what is the formula? Resistance is rho L by A. What is L? Length along the current flow. What is A? Area perpendicular to the current flow. So this resistance R12 will be how much? Rho, what is the length? You take the length in this direction, na? A. So rho A by area will be BC. So when you're going from up to down, what is the length? Length along the current flow. This is the length C. So rho C by AB. When you're going this way, what is the length? This is the length B. Rho B by AC. Are you getting this? So when you say rho L by area, L and area is different for different phases. Multiply and divide by A, B, and everything in here. This will be rho A square, ABC, rho C square, ABC, rho B square, ABC. So this would be A square is to C square is to B square. Check. That's the ratio of the resistances. So be careful. Most people have that problem. Ask them what is the formula rho L by A. What is L and A? They have no clue. This problem clears that out. Depends on which phase you're connecting the battery, length and area will change. Do have a look at this. All clear with this? Any doubts on this? Dipanshu, clear? Trisha? Next one. We have a cylindrical resistor. The radius is A. Resistance is R. And length is L. You don't require actually. Someone took this and this recasted it. It is melted. And it is recast. Into a rod with square cross section. So you took this cylinder and you melted it and you made a rod with square cross section. Kind of like your KitKat bar. Like this. Where the square cross section ka side is A and A. Find the new resistance. Nothing. Length के बारे में कुछ नहीं बताया. You took a solid cylinder, resistance R, and you melted this and made into a KitKat bar, a square cross-sectional rod. Right, Ammu, that is right. But try. That logic is right. Start from that. The cross-section area ka is just square cross-section side hai. Find the new resistance. Finish off. Last one for the day. Next class we'll do more like circuits and everything what we did. We will do different types of things which we couldn't do in capacitor. Then we'll do some regular circuits also. Everything will come, nodal analysis, symmetry, वो सब आएगा एक बार revise कर लेना.
Sir, can you repeat, sir, what you told nodal analysis?
Nothing. Solve this question. It's not important. I just said revise the capacitors का nodal analysis, symmetry सब revise करके आओ next class के लिए.
Okay, sir.
Now see, you can, what is same here? Volume is constant. When you're melting it, volume does not change. So rho resistance is rho L by area. So here I know area, I don't know length. So multiply area by area. This becomes rho, area into length becomes volume by area square. So resistance is proportional to area square. So initial distance R by R final will be A final square by A initial square. A final will be A square ka whole square. This will be pi A square ka whole square, which is 1 by pi square. Therefore, R final will be pi square into R. बस इतना ही करना था. There's no need to find the length. You can just eliminate the length by getting a, the volume. Same thing you could have done like this also. Rho is equal to rho L by area. You can multiply, divide by length and length. If length is given, rho L square by volume. So if you use this if length is given. Clear? Do check this out. There. So that is some of the questions on the theory. So please make sure to go through this theory. It's like there's a bit of a theory today. Then start solving capacitors. Finish it off. And next class will be on Saturday directly. So we'll be catching up on Saturday and Sunday, 9 to 10:45. Okay, so you have time till Saturday. Do as much as you can in capacitors. And at least try to finish off capacitors by next week. Don't delay too much by next Monday at least, because you have a test coming up. And your PACE major test is in when September 2nd only. Zyada time nahi hai, only 1.5 months left. These people, and they're rushing portion like mad. We won't be able to rush portion, but jitna hoga, we have to go at our own speed. The way it is going on, we will wrap up the portion just before Diwali. Full portion means advance sab ho jayega before Diwali. So then you get a Diwali ka break for 1 week, and then we'll start off the revision. Why bol raha hu? Till that time, I want you to finish off all these chapters which we are doing now properly. Then we will have around 6 weeks left. 6 weeks may, in that also there will be a lot of test series. Wo sab hoga. Maybe we will get barely a month. In that we can revise few important topics, and I'll be taking a revision of all chapters. We will do some a lot of problem solving. That's the best thing to do at that point of time. So we'll plan it out. So don't mess it up. Start working on this. Do finish it up. Okay. So with that, we'll wrap up for the day. I'll see you on Saturday at 9 o'clock again. So Friday there is no class. We have shifted it to Friday, Sunday now. So I'll catch up on Saturday again. So take care, stay safe. I'll see you on Saturday. So any doubts, anything, please stay back or also free to leave.